Have you ever found yourself completely baffled by a piece of software, or just wanted to throw your device out the window because the interface made literally zero sense? Well, you are definitely not alone. Welcome to this explainer. Today, we're taking some pretty complex human-computer interaction theories and transforming them into a highly structured, exam-ready guide. Whether you're staring down a 100-mark subjective exam, or you're a designer who just wants to build better systems, consider this your definitive roadmap. We've got a seriously packed syllabus today. We'll be running through the core goal-directed design process, unpacking user research methods, modeling personas, and tackling mental models. Then we'll wrap up with behavioral patterns and, crucially, accessibility. Let's just jump right in. All right, part one, the goal-directed design process. Let's get right to the roots of that device-smashing frustration we talked about. So here is the fundamental issue. When building a computer system, developers often make the massive mistake of expecting everyday people to think like computers. They ask users to perform these rigid, difficult operations that might be a total breeze for a machine, but are completely unnatural for a human brain. This leads to clunky software where the actual user is essentially ignored. Enter goal-directed design. It's the ultimate fix. It's a user-oriented approach that systematically centers everything around the person who actually has to use the thing. To actually bridge that gap between developer and user, you absolutely need to memorize this 6-step sequence, especially for those subjective exams. It's a continuous flow. We kick off with research. That data feeds directly into modeling, which then defines our requirement gathering. From there, we establish the framework, go through refinement via testing, and finally provide ongoing support. Follow this, and your system's operations will actually match the user's expectations. Moving on to part two. User research, specifically qualitative versus quantitative data. Because let's be real, in that first research phase, you can't just guess what people want. This contrast right here is absolute gold for your exams. Quantitative research, that's your cold hard numbers. It answers how much or how many. It's great for forecasting usage, like figuring out how many users are logging into a food delivery app at 6 p.m. Qualitative research, on the flip side, is all about the why. It dives deep into behavior, attitude, and aptitude. It tells you the environmental context of the user, giving your design team incredible credibility. You absolutely need both, but they do completely different jobs. So, how do we get those deep qualitative insights? We rely on 4 main methods. You start with stakeholders to figure out the business vision and budget. Then you talk to subject matter experts, or SMEs. Now, they might not be the daily users, but they ensure your product hits strict industry standards. Next up, customer interviews, which helps separate why someone buys a product versus how they actually use it. And finally, my favorite, ethnographic interviews. This is where you plunge right into the user's real-world environment to see them in action. Now, if you get an exam question asking you to evaluate specific interview methods, keep this in mind. Direct methods, like getting someone on the phone, are amazing because you can ask follow-up questions and really dig into their experience. The catch? It is incredibly costly and super time-consuming, compared to just blasting out a paper survey to 1,000 people. It's a trade-off. All right, section 3, modeling users. This is where we take all that raw interview data and synthesize it into something designers can actually use. This is definitely Tier A material. We have to strictly categorize user motivations into 3 goal types. First, experience goals. This is about how a user wants to feel. It guides your sensory, emotional design. Then you have end goals. These are all about just getting things done effectively, which drives your task flows. And finally, zooming way out, we have life goals. These are the user's long-term desires, like personal success, which ultimately informs the long-term positioning of your product. And here is the exact step-by-step sequence you need to construct a persona. First, you identify behavioral variables from your research. Second, map your interviewees to those variables. Third, spot the patterns. So whether you are designing a fitness app, a ticket vending machine, or software for dyslexic users, you synthesize those unique patterns into specific characteristics. Step 5 is crucial. Check for redundancy so you don't end up with 5 personas that are basically the same person. Finally, expand their attributes to really bring them to life, whether that's an elderly user, a busy farmer, or an overwhelmed student. The absolute biggest takeaway here? Personas are not just fictional characters you dream up in a meeting. No way. They are composite archetypes built directly from real observed user behavior. They are your best defense against self-referential design, which is just a fancy way of saying a designer building what they want rather than what the user needs.
It also stops the elastic user problem, where a developer constantly changes the definition of the user just to justify adding a cool new feature.
Section 4. Mental models versus implementation. Because listen, even if you have the best personas in the world, your design will completely tank if you don't understand how your users actually think. As a designer, your main job is to bridge a massive gap. On one side, you've got the implementation model. That's the cold, hard code, how the machine actually works under the hood. On the other side, you have the mental model. This is the story the user tells themselves in their head about how they think the system works. Your goal? Facilitate a conceptual model in your interface that actually matches the user's mental model, not the developer's complex backend. To help users build that accurate mental model, we lean heavily on Norman's principles. A huge one is signifiers. Think of an affordance as a hidden clue, but a signifier is the explicit physical form of it, a giant red hand that says stop, the word push literally printed on a door. Signifiers explicitly validate the action the user is already thinking about taking. Then there's mapping. This is simply linking a physical control to a highly predictable consequence. The classic example is a numbered dial for a fan. Turn it to a higher number, you predictably get more air. It's simple, it gives immediate feedback, and that repeated positive feedback is exactly how a user builds a solid mental model. But what happens when a mental model violently clashes with the system model? You get legendary tech support calls like this. A customer genuinely thought their CD-ROM drive was a retractable cup holder. Why? Because in their mental model, a little tray sliding out perfectly afforded holding a cup of coffee. The machine said optical drive, but the human brain said beverage holder. This right here is exactly why crystal clear design is so important. Which brings us to Section 5, 6 user behavioral patterns. Understanding those funny psychological mismatches leads us right into categorized usage models. If you're taking a subjective exam, write these 6 patterns down. They literally map the entire user journey. You start with explorative behavior, pure trial and error. Then you transition into learning behavior and inevitably hit problem-solving behavior when you get stuck. Over time, you achieve skilled behavior and eventually automatic behavior, where you're using the app through pure unconscious habit. And running parallel to all of this is social interaction, where users are connecting with others through your system. And here is where theory becomes practice. These patterns dictate exactly how we design for different experience levels. Beginners are exploring, right? So we must give them safe, error-tolerant environments. Intermediates are learning, so we support them with tooltips and progressive disclosure. But your experts, they are operating on pure muscle memory. For them, you absolutely must provide accelerators like macros and keyboard shortcuts so your interface doesn't slow them down. Finally, Section 6, designing for accessibility. Because true goal-directed design isn't just about making something look sleek, it's about making sure it's usable by absolutely anyone. Accessibility has to be baked in from day one. Planning, design, testing, not tacked on at the end. For visual disabilities, you have to ensure compatibility with screen readers and enlargement tools. For physical movement, voice input systems and alternative keyboards are a must. And here's a huge one for cognitive and language processing. Never, ever flash a critical error message on the screen and automatically hide it before the user actually has time to read and process it. So, as you gear up for your exams or your next big UI project, I want to leave you with one final question. Take a hard look at the systems you use every day and the ones you plan to build. Are you creating software that forces people to think like a machine? Or are you doing the hard work to adapt your design to the human? Keep the user's goals front and center, and you won't just build functional systems, you'll build things people actually love to use. Thanks for joining me on this explainer. Keep studying, keep observing, and keep designing for the human mind.